All right, this is skill practice A1 for your pre-algebra class. This is 20 problems, essentially the main stuff you need to know for the school year. Now, this is the baby step of these concepts. They'll keep growing in complexity as the year goes on. So here we go. So this first skill is 8.1. And if you ever have trouble with these concepts, if you look in our YouTube playlist collection, go find 8.1 videos, and that should explain how to do this. Some of those videos are still being made. Let me know if you need to see a specific skill. So we're comparing using greater than, less than, or equal to. We have 7.2 times 10 to the negative 2. We have 72%. I recommend for this type of problem you make them both into decimals. This means, this is scientific notation, you're sliding that decimal 2 places to the left, you're going to have this. 72% is going to be 0.72. So when looking at the tenths places, you see that the 7 is larger than the 0, so we're going to put in a less than symbol. Moving on, we're going to go through this rather quickly. So choose any number that is an integer. An integer. So integers are whole numbers and their opposites, such as these. So 2/3, nope, not going to work. 12/3 is going to be working out to 4, so that could be considered an integer. Negative 16 divided by 8 works out to negative 2, that could be considered an integer. 75%, no, because that's 0.75. 200% is the same thing as 2, so that works. 4 2/10, nope, not an integer. So these three are your integers. Moving on. Square root of 10 is between what pairs of consecutive integers? Okay, this can get tricky. Square root of 10, if we look at a number line, square root of 10, first of all, is not 5. A lot of kids will say it's 5, but 5 times 5 is not 10. It's actually going to be a decimal that goes on forever and ever. It's what's known as an irrational number. Square roots of non-perfect squares are irrational. So square root of 10, what we want to do is think of a perfect square that's really close to it. And if we think about it, square root of 9 works out to 3. Square root of 16 works out to 4. So square root of 10 is going to be somewhere in between these two. It's going to be somewhere between 3 and 4. Now you also need to remember that square roots of numbers can have negative numbers because negative times negative makes positive. So we could also say square root of 9 is negative 3, square root of 16 is negative 4, and we could think of it as between negative 3 and negative 4 as well. We'll be eventually having a video explaining this a little more thoroughly. Square root of 400. 20 times 20 is 400. Negative 20 times negative 20 is also 400. So you could see it as positive or negative 20. Most of the time, if they're just giving you the positive radical sign, they'll just want the positive. If they want the negative, they'll have a minus sign in front of it. So just be aware of that. All right, consumer application. What is the sale price of a $45.32 shirt that has a 20% discount? There's two ways you can do this. You can do it using a translation where you say, okay, original cost minus discount amount. If they're asking for sale price, there's two operations involved. You've got to do your 20% of the cost and then subtract it from the original price. So this is the percentage of the cost, and then we subtract it off. Another way to do it is to do a proportion. If it's a 20% discount, that means you're only paying for 80% of the original cost. So you could set it up like this. 80% is the same thing as something out of 4532. We'll go into a deeper lesson on this later, but this is the gist of it. So if you do, to solve for n, you could go 45.32 times 80 divided by 100, and you get the same thing. Those are both ways of doing it, whatever way works for you. They both come in handy. All right. Consumer application of percents, principal, loan, and time. Okay, and loan interest rate. If interest equals principal times rate times time, what is the interest amount for the loan above? Okay, just remember I equals PRT. Some kids think of it as I party, whatever works. Interest equals percent times rate times time. Basically, they give you the information in this problem. They just tell you the principal. You plug in the numbers. The principal was 3,000. The loan interest rate was 7%. Make it into a pure decimal. And then the time to pay off. So the interest is going to be $1,050. To borrow $3,000 and pay it off in 5 years, you have to pay an extra $1,050. That's why sometimes it's better just to save up the money first and not pay off loans. This loan cost you $1,050 just to borrow $3,000. Moving on. Angle relationships. Okay, we have this intersection here of 3 lines. All these angles have been created. They're asking about angles 1 and 2. They're next to each other. They share a ray between them. That's known as adjacent. So they're adjacent. They share a common ray between them and they don't overlap. But also, they're next to each other and they add up to 90 degrees, because if this one's 90 degrees, this is also going to be 90. And that's called complementary. So they're adjacent and complementary. This time we had 2 words that properly describe them. That's not always the case. Sometimes it might just be 1. All right, so volume and surface area. So they're saying we have a cone. Its height is 12, its slant height is 13, its radius is 5. And they want to know the volume. Well, we can go over here. We have our cone picture. We have 1/3 pi r squared h. R stands for radius, and they gave us the radius. H is the height. They gave us the height. Now, in this information, they gave us the slant height, but we don't need to know the slant height for volume. So you just plug in what you know. You can use your Desmos calculator for this. Set it up properly. 1/3 pi radius squared times height. And it works out to about that. We rounded to the hundredths here. We're going to move on. So this is the formula you would want to use for this problem. All right. So we have this figure. We have this square. Let's figure out its original dimensions, and then let's double the height and figure out what its new dimensions are. So its original figure, it's a 1 by 1 by 1. Length, width, height, they're all 1. Its volume, how many cubes is this creating this figure? It's 1 cube, 1 block. Its surface area. Its surface area, well, I see 3 faces here. I see a square, and a square. Now there's 3 that we see, but there's also 3 that we don't see. So there's a total of 6 squares covering this figure. Just like any cube has 6 faces on it. So if we double the height, well, that would mean we're putting another block on top of it. So now we have a length of 1, a width of 1, and a height of 2. So it's a 1 by 1 by 2. The volume is now going to be how many blocks? Well, we have a block here and a block here. That's going to be 2 blocks. The surface area was 6 squares. I currently see 1, 2, 3, 4, 5 that I can see. There's also 5 that I can't see. That's a total of 10 squares that you can't see. We'll talk more about this when we dive into the real lesson on this, but this is 8.6b, changing attributes. There's a video you can check out to study this further. All right. Transformations. So this is a 7th grade skill that we're reviewing right now. From A to A prime. A to A, the image of A. So A was here, and now it's over here. So it looks like it's going right and then down. So right is a horizontal move, and it's going right, so it's positive. So a horizontal translation, that means it's sliding. Right 6, and then vertical translation of -2, that means down 2. So if I was right here, I went 1, 2, 3, 4, 5, 6, and then down 2. So it's going to be Oh, we could also look at it as, I'm sorry, you could think of it as right then down, or you could think of it as down then right. Either way works. So a vertical translation of -2, check. Horizontal translation of 6, so it's going to be this one. Moving on. Pythagorean Theorem. Okay, this is true for any right triangle. For all right triangles, side A squared plus side B squared will equal side C squared. So sides A and B are touching the right angle. They're known as legs. A side that touches the right angle of a right triangle are known as the legs. And then C is called the hypotenuse. It's directly opposite the right angle. You'll hear those words a lot this year. So they're telling us A is 5, B is 12, and C is something. So we don't know what C is. So what I'm going to do is set this up. A squared plus B squared equals C squared. I'm doing something squared plus something squared equals C squared. They told us what A is. They told us what B is. Now we're just doing some order of operations here on the left side of the equation. I'm going to go ahead and work this out. 5 squared, 12 squared, we get this. Let's add these two together. We get this. So C times C is 169. That means if you take the square root of 169, you can get the square root of C squared. So it's going to be 13. 13 times 13 is 169, so 13 is that missing side. We're going to move on. Okay, so we have a trapezoid. Now this is hopefully you're thinking this is pretty basic. For a trapezoid, the area is 1/2 height times base 1 plus base 2. B1 means one of the bases, B2 is the other base. The bases always have to be parallel. So we've got 1/2 of the height being 5. A lot of times the height will always have to be perpendicular to the two bases. So we've got 1/2 of 5 plus 6 plus 10. So we've got base 1 and base 2. This 7 over here is not needed to figure out area. It's not parallel to anything, and it's not perpendicular to anything. So it can't be counted as a height or a base. So we're going to plug in what we have here. So we're going to go ahead and do some order of ops. You could plug it all into Desmos and get an answer. 6 plus 10 gives you 16. It ends up working out to 40. So the area of this figure is 40 square centimeters. Moving on. So probability with independent and dependent events. What is the probability of flipping heads on a coin and rolling a 5 on a number cube? And then are these two events independent or dependent? Well, here we go. So basically all you need to know, probability of heads, then rolling a 5. So this is heads on the coin, 5 on the number cube, or a dice. So you find the probability of each event and then multiply them. The probability of heads on a coin is 1 out of 2. And then on the number cube, there's 1 5 out of 6 possibilities, so 1 out of 6. Just multiply them. You're done. Now, are these two events independent or dependent? When you flip that coin, does it have any effect on the rolling the number cube? No, it does not. They are independent of each other. The coin does not influence the number cube. We're moving on. Box plots. This is just to read a box plot. Lower extreme is the smallest number that appears in this picture, and the lower extreme is going to be this lowest value represented by the end of this whisker. We'll talk more about this in the official lesson. Lower quartile is the edge of the box that's to the left. So that's aligning with 13. The median is going to be this line in the middle of the box. The median is going to be 16. The upper quartile is the top of the box, which aligns with 18. And then the upper extreme is going to be aligned with the tip of the whisker on the right. That aligns with 19. We'll go into more detail on this in class, but this is just a quick way of looking at it. Moving on. Scatterplots. What kind of relationship is showed in this picture? Well, from left to right, it seems like the dots are going downward. So that means as this x value is going up, the y value is going down. If you remember slopes of lines, when you see something like this going downward from left to right, it's a negative relationship or a negative slope. So it's going to be a negative relationship. Moving on. Simplifying expressions, simplifying this number statement. 5n plus 2 plus 8n plus 1. Now, we don't know what n is, so all we can do is regroup like terms. We can say this 5n and 8n go together. We're going to get 13n. We can say 2 and 1 go together. They're both constants. You're going to put those together, you get 3. That's all you can do with it. This is simplified. If we knew what n was, we could evaluate the expression. We'd plug in n, work it out to a single number, but we can't do that. All we can do is leave it as 13n plus 3. Moving on. Functions. So functions are relationships between two values. Is this table a function? So basically, if you have all x's that don't repeat, and they're all giving out just different y's, it is a function. Each input, the x, has one output. So 2 gave 3, negative 2 gave 6, negative 1 gave 1. If they listed 2 again and it gave a result of something other than 3, then it would not be a function. That's the main thing you need to know. The domain is the set of inputs. So basically, 2, negative 2, 1, order them from least to greatest. The range, 3, 6, and 1, that's the output. That's the set of outputs. And once again, I'm ordering them from least to greatest. And that's that for this part of functions. So linear functions. This is when you have an input and an output, and you graph them, and you get some kind of line created. So making a table, if you plug in for 2, you have 2 times something minus 1. 2 times 2 is 4. You get minus 1, you get 3. If you plug in a negative 2, and I'm also going to plot the point. 2, 3, hey, here's 2, 3. Negative 2, if I put in a negative 2, I get 2 times negative 2 is negative 4 minus 1, that's negative 5. I'm going to go ahead and plot that point. Negative 2, negative 5. There it is. Negative 1, if I put in a negative 1, 2 times negative 1 is negative 2 minus 1, you get negative 3. Negative 1, negative 3. There it is. Do those points line up? They sure do. The slope of this line, I'm going up 2, right 1, up 2, right 1. Up 2, right 1. And wait a minute. Oh, and then, so I'm going to come back to that. Now we're talking about the y-intercept. So it's hitting the y-axis at negative 1. The y-intercept hits the y-axis at negative 1. There it is. Now check this out. Hopefully some of you already saw this already in 7th grade. If you notice, your 2 is the same thing as your slope. Your coefficient will be the slope. Your y-intercept, your constant will be your y-intercept. Works every time. The coefficient tells you the steepness of the line. The y-intercept tells you, or the constant tells you the y-intercept. And we'll do some full lessons on that as well. Moving on. Multi-step equations. So this might be new for some of you, but this is just one step away from looking like a regular equation that you've done. So they want you to solve for n. Basically, you want to get all your n's on one side of the equation, all your constants on the other side. So check this out. Let's get rid of our n's. Let's get all our n's to one side. So I want to get rid of this 3n. So I'm going to take it away. If I take it away from here, I take it away from the other side also. 5n minus 3n gives me 2n. The 8's left over, the 20's left over. Now this is looking more like a standard equation that you did previously. So now we're going to subtract off the 8, and we get 12. We're going to divide by 2, and we get n equals 6. Now you can always check it. You can say 5n plus 8, plug in that 6, 5 times 6 plus 8. Is that equal to 3 times 6 plus 20? You could use Desmos to check it, or you can just work it out in your head. Hey, 30 plus 8 is 38. This is 18 plus 20 also gives you 38. So it does work. All right, this is it. A two-step inequality. It's a lot like what we just did with the equation. Let's get all our variables on one side, our constants on the other side. In this case, I'm going to get my constants all over on this side. I'm getting rid of that -4 by adding 4. And I also have to add it to this constant. Now I'm going to get rid of my 3, and notice how I'm not dividing anything out yet. I'm just subtracting it off. So I'm taking away 3n, taking away 3n. And now I'm going to divide by 3, and I get n is greater than 8. So then we find 8 on the number line, and we do an open circle going to the right. That is it for this skill practice. Hope this helps. Best of luck to you.